what is this technically? It's not f prime. Well, you could say it's capital F, but that's not how they actually put it here. They just put it as regular f, okay? So here it's defined as just f of x. If we want to, we can go ahead and simplify. X squared to the 4th is actually what? X to the 8th plus x squared, and I don't really have to put the minus 0. This is the function of x. Now, this is not what it's asking for. What is it asking for? Find f prime. Okay, I can do that. I know how to take this function and find the derivative. So f prime of x is actually equal to 8x to the 7th plus 2x. Now, you could go a little bit further. Let's say I was looking for like critical values. What could we do with this function? We could, if we wanted to, we could set it equal to 0 and solve. I would factor a little bit. So we're not going to set it equal to 0. But I just want to let you guys see that this is also what factors out of both 8x to the 7th and 2x. 2x, which leaves us with 4x to the 6th plus 1. Okay? You don't, but you'll see why I did later on. Okay? So, this is the derivative of that function. You guys see what we did? We integrated, we plugged in our values, then we took a derivative. It looks pretty similar, doesn't it? Do you see it? Like this 4t cubed plus 1. Here we have 4x to the 6th plus 1. Okay, and then we have that 2x on the outside. So, let me show you the shortcut. I mean, you could do this every single time, but I'm going to tell you it's a pain in the butt. So if they want a derivative, and they're trying to say, here's the function, but you have to integrate to get the function, and then they want a derivative, here's what you want to do. I'm going to try. I'm trying to think of how I want to do this. Give me a minute. Give me a second. Trying to think of how I want to phrase this to you guys. Okay. It is. Okay. Nope. I'm just going to go for it, and then I'll explain it after. I'm going to. Yeah. I'm going to do it first, and then I'm going to explain it after. Okay. Notice I'm starting with the exact same thing, but I am going to skip a step. Okay. Now, guys, what are we looking for? We are looking for. Kind of. You'll see. Well, okay. So let me explain. Do you agree that if I integrate this, I got this function, right? Yeah. What would happen if I took the derivative? I got what was in the integral. Yeah. Do you guys see that? Here's this, integrate it. If I took this, took a derivative, I would get that back. Yeah. Yes? Yeah. Okay. Here's what I'm going to do. I am not going to solve for f of x. I am going to go straight to f prime. Okay? So f prime of x is actually going to be equal to this. Okay? Okay. Sorry. Do you agree that at some point I had to take a derivative of x squared? Yeah. Okay. Times, instead of having t's, what do I want it in terms of? X to the 2nd, right? You guys okay so far? Yeah. So I know I need to take a derivative of my upper bound, and I also have to plug in my upper bound. Okay? I'm going to subtract. I have to take a derivative of my lower bound. And I also have to plug in my lower bound.
That just seems, it seems longer.
It's not.
And it's faster.
It looks a little bit more complicated. It'll be easier in a second, okay? So now we're just going to follow exactly what I see. Okay, take a derivative of x squared. What is that? 2x. Can I simplify this? This 4x squared to the third plus 1. What does it become? 4x to the 6th plus 1. Can I take a derivative of 0? Yeah, you can. What is it? It's 0. What do you notice? It's already the factored version. Okay?
Dang, I was not ready.
That's a minus or no?
That's a minus. Okay? So let's explain what just happened. If I'm taking an integral and finding it, and then I'm taking the same thing and deriving it, the only thing I have to worry about are my bounds that I'm plugging in, right? I understand that I can plug in my bounds here and subtract them, right? What you need to take into account is taking derivative of your upper bound and taking a derivative of your lower bound to get this to work out nicely here. Okay?
So, for the d, like the first d over dx, x squared,
Mm-hmm.
like I'm just going to call it d for now. So, like, it's not b, but it's x squared. But you would have to do the x squared first, and then the 0.
Yep, because this is your upper and this is your lower.
Obviously, upper always goes first.
Always. Guys okay? All right. So you're going to see it again with example 2. We're going to do it the long way first, and then we're going to do it the shortcut way, okay?
We'll lose lines, man.
I know. Okay, so again, we're going to be finding f prime of x. So we're going to do it the exact same way. We're going to take an integral, we're going to plug in our upper bound, plug in our lower bound, simplify our function, then take a derivative, okay? So we are given that f of x would be equal to the integral, ooh, you're going to hate this, all right, pi over 2, 4x plus x squared, okay? And I'm doing sine of t dt, okay? It's not awful, it's just, that's what it is. Now, let's go ahead and integrate. You better get this integral right. What happens if I integrate sine t? Negative cosine t. Upper bound is 4x plus x squared. Lower bound is pi over 2. This is, again, our function, right? This is f of x. Now what do I have to do to actually find the function? We have to plug in. Well, we have to plug in for t, but yeah, I know what you're saying. So negative cosine, now guys, make sure you're using parentheses. 4x plus x squared, okay? Minus negative cosine of pi over 2. Again, this is still our function. Can we go through and simplify? Do we know a value for cosine of pi over 2? It's just 0. So we get that f of x, am I running out of space, is equal to negative cosine, parentheses, 4x plus x squared minus 0. Are you guys okay with that as our function? So far, so good. But that's not what it wants. What does it want? It wants a derivative. Oh, what kind of rule do I have to use for the derivative? We have to use a chain rule, because I have a function within cosine, okay? So now, if I find f prime of x, what is the derivative of 4x plus x squared? Yeah, 4 plus 2x. What's the derivative of negative cosine? Sine. Weird. And what am I putting into this sine function? Plus x squared. And what's the derivative of 0? 0. So that is my derivative. You guys ready for the shortcut?
So we'll just leave it like that. We don't have to like worry.
Oh, 4x. Yes. 4x plus x squared. Good call.
So we leave it like that. We don't have to simplify it at all. Or...
No, that's it. It's factored. Everything's fine, right? Okay. So let's do the shortcut. Okay, now let's make sure we really understand the shortcut. So again, we're starting with this function f of x is equal to pi over 2, 4x plus x squared. My function is sine t dt. F prime of x. If it's f prime, that means if I integrate with bounds, I have to take a derivative of your, where do we start? The upper. Okay. So I need to take d dx of my 4x plus x squared. See how this is a dt? This is already a what? What does dt stand for? This is already a derivative, so do I have to take a derivative of sine? No, this is a derivative. So what am I plugging in for t? Just your upper bound. Does that help clarify things a little bit? Okay. If we're looking for a derivative, this 4x plus x squared is not a derivative. Does that make sense? But this sine t is already a derivative. So when I go and plug in for t, it's just sine 4x plus x squared minus your lower bound. Is that derived yet or not? No. So d dx of pi over 2 times, I'm running out of space, sine of pi over 2. Sorry, I know. Now, let's go back. What's the derivative of 4x plus x squared? 4 plus 2x. Leave it in parentheses. That doesn't say to take a derivative, so it's just sine of 4x plus x squared. What's the derivative of pi over 2? 0. And now we're automatically back. That's it. This is f prime of x. Okay. So let's do one more only using the shortcut because you guys don't know how to integrate using the other way. Okay? Because I'm going to give you guys a function where you can't integrate it. You'd have to do integration by parts, and that's a BC topic. Okay? So, example 3. Find f prime of x. Okay, so you'll see what I'm talking about in a second. So here's f of x. We're only going to do the shortcut because you guys don't know how to do it the long way. It's called integration by parts. You're not going to learn it in here this year. Okay? And I would have to remember how to do it. Okay. So we are, whoa, it says f of x equals, we're going to be integrating from negative 2x to x squared. It's okay. We're going to just follow the same thing.
I'm not ready. There's another variable in there.
Times tangent of t. What is going on with the camera? Okay. I did. So guys, do you see what I'm talking about? We don't know how to integrate that. Okay? If we were taking derivatives, things would be fine, but we don't know how to integrate. Okay? So again, like I said, we are going to use the shortcut way. So let's just think about what I'm doing. First of all, what am I going to call this down here? What is it? It's going to be f prime. Okay. Is x squared a derivative? No, but I want a derivative, right? So I need to put d dx of x squared. So far, so good? Is t tangent t a derivative? It is. So what am I plugging in? What am I plugging in for t? X squared, exactly. So I'm going to put x squared times tangent of x squared. Hey. Stupid camera.
You gotta give it love. And we're gonna put it last time.
Come on.
We all have to sing.
Oh my goodness. What is going on with you? Come on. There you go. Okay. Okay. You guys good so far? This is my upper bound. What are you supposed to do with your lower bound?
Subtract it.
So we're going to be subtracting. Is this negative 2x then in a derivative yet?
Nope.
No. So it's d dx negative 2x. So far so good?
Yeah.
Okay. T tangent t. Is that a derivative? Yes. So what am I going to put in for t here?
2x,
Negative 2x tangent negative 2x. Now guys, I'm just going to follow it exactly what it's telling me to do. Here, take a derivative of x squared. What is that? 2x. Here, do I have to do anything with that function? Nope. Okay. Here, what is it telling me to do? Okay, what's the derivative of negative 2x? Negative 2, but since I'm subtracting it, let's put plus 2. Do I have to do anything with this function? Nope. And here's your answer.
So we don't have to do like terms or anything?
No. Okay. You could pull out a 2x from both of them. Okay, like if you did, no, guys, it's not that big of a deal. If you pulled out 2x, right? Like that would leave this as just x squared, tangent x squared, right? If I pulled out 2x here, that would leave a negative 2, tangent of negative 2x. Okay? And again, this is the derivative of f of x.
Wait, why would it be negative 2 if you put out a positive?
Okay? So if I pull this 2x out, I still have a what here?
Oh,
That negative with 2 will make a negative. Okay? All right.